Welcome everyone to the fourth Share It event. I am Vanessa Famicora and I am a developer in ThoughtWorks. So for who's not familiar with ThoughtWorks, we're a global consultancy. As you can see from our slides, we are global. So we have offices in 48 countries. Sorry, we have 48 offices in 17 countries. And we've been in business for quite a while. You might have heard of us because part of our culture is to share knowledge as much as we can. So you might be familiar with the work of some of my colleagues because many of them have written books, or you might have met them maybe at conferences or we've come across the tech radar. So at ThoughtWorks, we really enjoy the opportunity to share what we've learned and to learn from others. And that's from that culture that the Share It community was born. So Share It is a community that was born in Italy and currently managed from there. It is a knowledge share platform for everybody in Europe or anyone who would like to participate. And we have a mission. So our mission is to empower individuals and organizations. We really want to help and support to others by sharing, the day-to-day experiences that we have. And we try and do that by having regular talks like this one that you'll see today and the ones that we had before on topics that are very varied, that reflect both like the day-to-day of our culture, for example, in our diversity and inclusions, but also in our day-to-day of our work. So today we have a security talk, we've had hard tech talks, we had more architecture talks, and we'll carry on having a range of talks that reflect what the kind of experiences that we've had. And among our speakers, we've had people working in offices all over Europe. So going to the next. This is our code of conduct. I know it can seem a little bit excessive for such a small community, but I thought we really care about being respectful with each other. And I think even in these online communities, in this new reality where we are together virtually, it's important to respect each other. So we ask you all to be excellent to each other, just be kind to each other. We want to make sure that everybody feels that their questions are valid. There's no such thing as a silly question, and we always learn even from the questions that people ask. We ask you to be kind and respectful. Sometimes there are debates. Please be kind to each other too. And among everything else, we ask you to be in the frame of mind that we're all here to learn, and we look forward to actually the debate with you if there's any. So now we'll finally have the exciting part of this talk, which is Lisa Junger talking about Unflashy security. So I'll stop sharing and hand over to her. Please, if you have any questions, write them in the chat and we'll show them to Lisa at the end of the talk.
Hi, yes, I am going to share my screen. Find the right window. So you can see. Vanessa, can you give me a thumbs up? I can see the.
Not yet. It's loading. It's perfectly normal. All the live things. Should see what happens when we have demos.
I'll try again.
Oh, no, it just appeared and I know. We had a talk where the Wi-Fi went off for the poor speaker. That was really hard.
Okay, maybe that's because
we can see it.
Okay, perfect. I was looking at the wrong focus. Okay, cool. Welcome everyone. Thanks for having me. I'm Lisa. I'm based out of Hamburg, Germany, and I can't see anyone, but I guess somebody will ping me questions if there are any. So please feel free to try and interact. We'll probably have most of the questions at the end because it's easier in this format. I am working with so we're a professional services organization, and I'm working with our engineering teams about all kinds of aspects of security. And with that, I've come across a lot of practices that have worked and a lot of things that kind of fall into general engineering practices or a little bit beyond that, but they're deeply connected to the way that we deliver software and value. And hence I've tried to condense my learnings. This is in no way like a complementary or like complete picture of everything that you could potentially know about security, but I'm hoping that I can, get across the ideas that are relevant and actually things that everybody in the delivery team can do. I do need to see someone, sorry. Just making this smaller. Is this still okay, Vanessa?
Yes.
Okay, cool.
Yeah.
I can't speak if I can't see anyone.
Oh, fine.
Cool. Okay, perfect. So unflashy security, that's the title of my talk, because I'm trying to talk about the unflashy aspects of security. Security is sometimes seen as like, a bit of a mysterious thing, even to engineers or product people that spend a lot of time thinking about it. So I want to kind of flesh out the things that we can all do. But maybe starting from the beginning, right? There's a very interesting page out on the web. It's called Information is Beautiful for all kinds of things. If you like data visualization, it's a good place to go. One of them is about the world's biggest data breaches and hacks. And here's a recent screenshot of that. And when you look at this, you can see that there's a lot of stuff happening all the time. It's probably something that you see in all your Twitter timelines and your media consumption. It feels like there's a next security breach or a data breach every day. And if you look at this diagram here, you can see that this happens to a lot of different kinds of companies. It happens to very big ones. Obviously, there are also bigger targets. It happens to very small ones that you feel like are more or less unseen. And it happens to organizations like, for example, your Facebooks or Microsoft that you can see here very prominently that have dedicated security teams in their own organization that spend a lot of time protecting the assets. You can also see, I don't know if it's on this one, but some of the smaller ones are even organizations that, like hacking team, for example, that whose business it is to exfiltrate data or hack other organizations for whatever reason, and even those get hacked. Right? So I guess when we look at this scenario, it kind of reveals to us that being vulnerable to hacks isn't a matter of whether this is going to happen. It's more a matter of when this will happen. And beyond that, what the blast radius of any given intrusion will be. So there's a process that's called responsible disclosure. Some of you may be aware of that. It's kind of the way that the internet community tries to protect itself from these kinds of things, taking the upper hand. It's people, all kinds of different people, researchers, developers, individuals, groups, trying to find vulnerabilities in software out there and making it publicly known to everybody out there, which seems like an odd thing to think about first, is actually a preventative measure, right? Because if you do this in a responsible manner, then the organizations that are vulnerable or that have produced this vulnerable software can implement patches, can fix things over a certain amount of time, and then make this patch available to all of us. So there's a few things like this out there. But on the other hand, that also means that there's people and tools out there that make use of these known vulnerabilities to find automated ways to scan the internet IP range and find ways to get into your software. Over the history of our craft, my feeling is that we've trained people to believe that security is difficult. It's something for experts. It's something that's, trying to create a state of being protected or secure. That is not what the reality is all about. And most of the things that, especially when we're talking about vulnerabilities as the ones that I just spoke about, they're things that require a solid and rigorous engineering process to be in place. And that's not something that security experts need to do. That's something that we can all do to protect our software estate. As a result of that, I think, maybe not just of that, but the evolution of our industry and the way that we do things and the practices that we apply, speaking about, agility, agile practices, extreme programming, etc. Security has always been missed in that picture. So we're still thinking that we can design a system, do some checks in the beginning, produce a system, and verify at the end. It's not really something that's actually working today, and we'll get more into detail of what we can do as part of this talk. So even in the second wave, if you want so, when we're talking about DevOps, security was missed again, right? So now we're not just producing software, we're also, somewhat responsible for the encompassing infrastructure to some extent. And yet again, security wasn't at the heart of this evolution. So I think we've now all seen things like shift security left, or some of you might have heard this buzzwords like DevSecOps. But what does this actually mean to me as an individual on a team, right? So some of the things that I think are integral part of that, we'll discuss today. And it all starts, or it all has the common theme of enabling the delivery team. And that's the core idea of shifting left, right? How can we make sure that everybody on our teams understands that we have to recognize that our code will be used in ways that we cannot anticipate, and in ways that it was not designed for, and for probably longer than it was ever intended to initially. You've all seen the classic prototype to go live, right? So it's not really an assumption that we can go by anymore, and it will kind of fall back onto the delivery team at some point. So how can we inject these ideas into our teams, and how can we take them along, and how can we give them practices that help them do things with security in mind? There are also obviously building blocks and architectural decisions and very specific security questions. When you talk about authentication, authorization, for example, is usually a thing that comes to mind first, right? Architectures like zero trust, ideas like principle of least privilege, defense in depth, observability, monitoring, and alerting. They're all contributors to a secure system. But what does this mean in the process, in our day-to-day? So we're not looking at the system, we're looking at the process today. Some of you may have read a book called Accelerate that was very prominent amongst engineers and the software delivery people over the course of the last, I think, 2 or 3 years. And it's basically made very clear that continuous deployment creates a competitive advantage that barely any organization can ignore anymore. And some of you may have something like this for their own delivery, but you see a somewhat prototypical software delivery lifecycle, right? Where in the very left you have where the things that originate ideas around products, features, and towards the right, the further you go towards the right, you're deploying into your production systems. And in the middle, there's a whole lot of stuff that happens, right, in order to continuously create value. When you look at that, it's fairly clear why we cannot treat security as a gatekeeper function anymore, and why we have to try and shift left and enable our teams. In ThoughtWorks, we have a few clients that push very, very often to life, right? We have one client that I think has been very, very open and sharing about this, Otto in Germany, who are pushing commits to production roughly 100 times a day. Now, if we have this like prototypical life cycle where we have discussion and verbalization of functionality, then we're trying to come up with requirements and making sure that we can actually engineer the things that we're thinking out. And we're doing analysis to break down stuff into manageable individual chunks of things. We're starting to develop our software. We're injecting quality analysis into the process, right? As early as possible into this process, and we deploy. Now, when we look at this from a security perspective, there's a few phases. I mean, there's probably other ways to structure this, but there's phases that you can think along when you want to like think about, what do I do? How can I harden my software delivery? And there's a phase that I call the design phase in the very beginning. Then there's a phase where we write code. There's a phase where we inherit all kinds of stuff because we're all standing on the shoulders of giants, right? Like we draw in our dependencies, we use infrastructure that's provided to us, all that kind of things. Then we build and test, mostly in an automated fashion in this kind of delivery. And then we deploy. But after we have deployed to a production system, we also continuously operate the system, right? Stuff is happening on our production systems and it's just out there as a product. So now, what do we do in the design phase? This is where the new requirements originate. Remember the improvements that are being analyzed, sometimes bugs that come in that need some further understanding or have some impact on our general design of the system. This is often a phase that includes product owners, subject matter experts, business analysts, requirement engineers, stakeholders, developers, quality analysts, the entire team. Right? Everybody needs to understand what is it that we're building. In this phase, when we're looking at it from a security perspective, we need to understand our threat model. We need to understand what we're building. We also need to understand what could go wrong from a security perspective. We need to think out what we're going or planning to do about it, or if we're doing anything about it. So we need to reason about impact and risk. And we have to continuously do this and wonder if we're doing a good enough job and find measures to understand when we're good and when we're not good. I'm going to dive a little bit deeper into this because I think this is, from my experience, is something that we often miss and put to the side, especially when delivery pressure is high. But it's a really important stage to be clear. Like we wouldn't do this with functional requirements, right? We need to understand what it is that we're trying to get to. So engaging in threat modeling over having a threat model is the theme of this. We want to make sure that we have continuous conversations with the team and all the stakeholders that are relevant to that, and sometimes subject matter experts for security concerns, to be really clear what it is that we're building and what the risk is that we're creating or getting through that. And this encompasses a few cornerstones of things that we need to understand. We need to know our assets. We need to know what is it that we're trying to protect. If all we have is public material, then likely your controls don't have to be as strict as if you're processing secret information. We also need to understand and explore our security goals. You've probably heard about the CIA triangle: confidentiality, integrity, availability of my system. So compromises to any of those can result in a disaster scenario against the security goal that I have. So if I have an impact and the size of that disaster, that's something that we need to understand so we can reason about controls that we want to put in place. We need to bring in all kinds of different functions to do that, because usually the development team in itself doesn't have all the information. What's the business reputation risk of something going wrong? It's usually a stakeholder outside the team that can give you that answer. The engineering team needs to make sure that the risk is described and explored, and then, you know, find a way to make decisions about how do we even address this risk. And then we want to continuously improve, because we can't do this, you know, like in a one big multi-week workshop. In a continuous delivery context, we need to do this over and over again as our system evolves. There's a lot of different ways to do this, but a few that I've seen work for different contexts. So you can do this on a per story level, right? So every story that comes in, or every epic maybe, you're taking and you look at it from a security perspective, you do an analysis, a future perspective of what compromise to security goal could happen given this epic is being played. We can look at it from let's say agile approach. These can all be like part of an agile approach, but a continuous threat modeling approach where you look at your system, a specific aspect of your system, regularly, like every 2 iterations or so, depending on, you know, what makes sense in your context, and you look at the present. So you look at what we have, we're playing this epic, what are we changing, what changes are we making to our current threat model, of the current understanding of our security posture, and, you know, what are the potential changes to our threat landscape, and how do we want to mitigate or handle those. And then there's an exploratory way, which is usually a bit more retrospective, looking at the entirety of the system, which usually is driven by security specialists more than the other two. Looks into the depth of different paths of possible attack vectors into your system. My experience, this is mostly needed in a bit more higher security relevant contexts. If you're in one of those, there's likely a lot of process already around this, but just for kind of, you know, the breadth of the landscape. One of the things that we do, at least in the 2 first ones that I think teams should continuously do, like the per-story threat modeling or the agile continuous one, is that we use evil brainstorming, which is basically a way to bring the team together, looking at the system landscape as it is today, identifying the different assets that are relevant in the current system, and then try and find out how we could do evil to the system. And Stride is a Microsoft-based idea around, you know, making sense of different types of attacks and vectors. That gives a good, handy, somewhat simple way to think about security and risk vectors, and using those as triggers, as cues to thinking about evil things that could happen given your current system. So there's a whole way, like, you know, whole approach of workshopping around this, but I think this is a really interesting idea, and we should do this continuously so we understand more about the risk and the potential threats in our system. Can maybe, yeah, I'll take some more time on this and you pressure me if I'm going over time too much. This STRIDE acronym is basically about spoofing identity, tampering with input, repudiation of action, information disclosure, denial of service, and elevation of privilege. So these are kind of the lines of thoughts that you go through and you do evil brainstorming around them. Spoofing is pretending to be someone that you're not. Tampering with input is, you know, something like injecting malicious code through a form or something like that. Repudiation of action is the question of how can I hide my traces if I was to be able to intrude into your system. Information disclosure is everything that allows me to see information that I'm not supposed to see, given my privileges. Denial of service is not just DDoS attacks, it's the overarching category of making a system unusable for its intended use case. And elevation of privilege is specifically escalating my privileges from the privileges that I have in the system to something that gives me more ability to do things. So that's the idea. And if you take these kind of cues, then every team can reason about threats and their threat model fairly easily. So the next phase, if you remember, is writing code. So now, we've thought out all the kinds of ideas. We're coming to, buckets of smaller things that we can actually implement as functionality. This involves a local machine, because it's usually done on some sort of device that you have somewhere outside of the system. And it typically involves developers, quality analysts, sometimes business analysts. So this is all about hardening the developer's machine and the developer's code writing process. The first question that I often ask teams is, do you know what would happen if your machine gets lost? What's the data that you have on that laptop or that station that you're working on? If that got into the wrong hands, is it protected? So there's all kinds of things that are usually organizational controls in most people's context that are provided with the machine from their employer or any kind of larger context that operates the system. But it's good to know, right? It's good to know, is my hard drive encrypted, for example? Am I using two-factor authentication when I use this machine to authenticate in some other context? The other question is there a chance for me to leak secrets? So often, even if we have sophisticated secrets management systems in place for the systems that we're running, is this also true in the development process? Or are there examples of things that you still have? Do you have credentials for test environments? Do you log into your cloud console with an individual token? How do we prevent these secrets from leaking? One thing, obviously, is trying to avoid to have secrets in code. It's simpler said than done. Especially when we're in legacy contexts, that's sometimes not the easiest thing to do, but it's good to use this as a Northern Star. Is there a way to use pre-commit hooks, for example, to check for entropy or something that indicates a secret being part of your diff that you're just about to check in? If you can prevent that, or if you have a tool that can catch you while you're about to push a secret out of the developer's machine, then that can be a lifesaver. It's much easier. Once it's out there, you need to rotate it. If you're lucky, you can find it quickly. So if there's ways to do that, do it. There's a tool called Talisman, for example. It's often used across ThoughtWorks. It has a few downsides. It needs a bit of configuration, but that can really, really help you, prevent yourself from making silly mistakes that can just be accidents. Avoiding shared secrets is another one. Using password managers, yet another one. There's also the question of whether we can support developers to write more secure code. So while I'm still doing my work, writing my code, there's practices around secure coding that I might not always be aware of. There's linters out there, or tools for static code analysis, for example. I think Find Security Box is one. There's a lot of tools. I think Ruby is using a tool called Brakeman. Depending on your context, there might be a tool that helps you to do static code analysis against security bugs. So if you happen to write, queries to a database in a way that's maybe not appropriate anymore, then that can, help you. And you can even integrate them into your IDEs. There's also linters for infrastructure code, for example. So if you're also writing your own infrastructure code, something that was on the ThoughtWorks radar, I think at some point, is called TFSec for Terraform code that helps you find, odd configurations or ways of configuring your infrastructure that are not ideal, and then you can review them and see if they are actually a problem, and that way kind of build this test harness for yourself. Sometimes there's still like this leftover bit of shell code that we all love so much. There's also a linter for shell that helps you find security issues. It's called shell check. And I've actually seen a lot of issues around accidentally committing a script that has, a set -x or something at the top because you wanted to debug something locally and then happened to push this into your pipeline, and all of a sudden starts printing out the information that it shouldn't. Needless to say, some of these things can also be run in the pipeline, but this just kind of thinking about what do I do on my local machine. If we go to the inherit phase, right, that's the phase where we're drawing all kinds of dependencies in order to even be able to sensibly develop any systems today. There is dependencies, there's also transitive dependencies, right? So there's a whole tree of stuff that comes when you're writing code, more depending on the language environment, but it's definitely a thing that I guess we're all familiar with. This typically involves, again, developers, potentially QAs, but it's mostly an automated process. And in the inherit phase, it's all about validating your dependencies. It's like being aware what code we're actually using that we're not writing ourselves. Speaking of transitive dependencies, right? Are we aware? Do we have a sense of where things are coming from? There's a whole array of supply chain attacks in this, where I don't know if you've read about this, I think a year or two ago, a researcher was finding this vulnerability where you could basically use it like all kinds of different dependency management tools and point the dependencies that you were trying to download with the same name into the dependency management library, and then pull a different version than what you're expecting to pull just by using the same name, and then basically injecting whatever code they wanted. And since it's an automated process, you wouldn't be aware of it. So understanding that, one thing. The other thing is detecting and patching relevant vulnerabilities. We've spoken about the responsible disclosure process, right? So what falls out of these are called commonly known vulnerabilities and exploits. There's all databases of them so that we can also, help ourselves protect against them or identify them. And there's a lot of tooling out there. Trivia is one of the open source tools that I think a lot of people in ThoughtWorks have used and have made really good experience with, to identify if in any of your dependencies or transitive dependencies, there is a commonly known vulnerability. So you can then go in and check whether you need to do something about it, use a different version, update, patch, whatever it is. Sometimes we're not using the relevant components, but that's a very thin line because you never know when you are in the future. And if you've already quieted your vulnerability scanner, they may not alert you again. So that, again, you need to do some tweaking and configuration, and that may take some time, but it's definitely worth it. The other thing is, can we avoid dependency drift, right? Thinking about regular patching of our dependencies, if we do not regularly update, even if there is no vulnerability known, then it's becoming so much harder to do that when you have to. So try and keep up to date with the dependencies that you have, because the small incremental changes are much easier to integrate into your software than after all this dependency drift has already happened. So this is a preventative measure. If you find a vulnerability, you'll be in a much better place to react to it. There's also an OWASP dependency checker. If people are familiar with the OWASP project, it's a very widely known web application security project. And they also provide one that's compatible with a lot of different ecosystems. There's a ton of tools that I'm talking about just because I'm remembering this now. ThoughtWorks is not being paid. Like, we have no relationship with any of those tools. Like, some of them we've developed ourselves, but we are not being paid to promote them. So just in case that question comes up, this is just things that we've seen work in production, and we're kind of, trying to share that. Dependency drift, by the way, is also a good way to formulate something called a fitness function. So if you're evolving your architectures, you're trying to kind of define a good state. What does this mean? What are you trying to have an architectural composition ideas and all kinds of different ways, paradigms that you want your system to adhere to. And dependency drift is kind of a simple version of that. Then we come to the build and test phase, right? Where we're building our systems, where code is deployed, where it should be tested for security expectations. This is usually done today in a CI pipeline for most cases. And this is all about automating security expectations. So I'm looking a lot at the testing idea. It's not necessarily always in that exact phase. I'm kind of breaking my own structure here a little bit just to kind of bring the right ideas together. But the first thing definitely is, usually, obviously, we do this in the beginning, but when we're saying testing, right, do we have security acceptance criteria when we're writing out the functionality that we're trying to deploy? Security is always part of a value stream, right? So it's creating value, and we should define it as such. And if we have them, can we translate them into automated tests so that we avoid any regression from them, right? So we want to make sure that when we have a certain status of things, we want to be able to keep deploying new functionality without breaking that expectation. There's also the question of automating attacks. Can we think of ways, like when we've done our threat modeling, can we think of ways to automate the attacks that we're trying to prevent from, so that we also have this regression testing in our system? We can say, we still know that we're not vulnerable to this certain type of exploit. Yeah? And there's a whole array of compliance testing opportunities out there, because beyond the pure security things that we're trying to do, there's expectations from authorities, there's expectations from security policies that we want to make sure that we're, we have a clear status against them. To give you some examples, right? For authentication and authorization tests, there's an interesting project also in the OWASP toolchain that gives you a way to, like a framework to formulate your expectation against your authentication authorization. And with that, you get a regression test for that. There is BDD type testing for certain expectations that you can phrase together with your quality analysts, your business analysts, your product owners, people that kind of have a better understanding of what the system is supposed to deliver. And then you can make sure that it's also a sort of a way to audit the status. against certain security expectations. Again, there's infrastructure tests. There's something like server spec, besides like TFSec that we've spoken about before. Server spec can formulate expectations to the status of your infrastructure. So you can basically start TDDing your infrastructure code and can say, this is what I expect the thing to do, and only when I get to green on this, I push it out, and then you have a certain level of assurance there. There's a bit of a different category when it comes to automating attacks, which often runs against the deployed system. So it's a bit out of scope here, but still, I think it's in the testing space to some extent. It's the idea of automating pen tests, maybe a bit of a broad statement, but I don't know if anyone has heard about OWASP Z-Attack proxy. It's basically trying to take OWASP top 10, like the top 10 web application securities, the security vulnerabilities that we find out there on the web, and make sure that basically run exploits against your deployed system, like your testing environment or whatever it is, and then you can see if you're good against those. That does not replace a pen test. Don't get me wrong. It's like, that involves a bit of a manual kind of trying to break things, but as a continuous process, right? If you already covered on that level, if you're building a web application, obviously that is, then you have a good status already for your system, and that you can do in an automated fashion. If you're on the cloud, you have to be a bit careful, read the documentation, because there's a few catches on that, but you can still use it. For continuous compliance, there's things like not simply, but let's say, very not fancy tooling. For example, if you're in the AWS, there's AWS config, where you can define configuration expectations, and you can alert yourself if some configurations aren't the way that they're supposed to. For example, if you know that you always want to encrypt your S3 buckets, then you can phrase that in an expectation. You can make sure that whenever that's not the case, you get an alert on it. A similar idea, security policy as code. So trying to not just write policies on paper and put it into a drawer where nobody can ever find it, and potentially developers will not understand what it's supposed to mean. You can translate them into code. That way you can assure that we're all of the same understanding of what that means, and then you can test against it. This is often around identity and access management. There's a bit of a sophisticated outlook for that. Some organizations do that, not many yet, as far as I know. And it's called binary attestation. And that is used to assure deployable units have actually passed all the checks that you want, like that you've agreed to pass. It's a bit of like an automated governance type thing. Basically saying, whenever I pass a certain check mark in an automated deployment system, I get a signature on the binary. And then at the end, you can validate whether all the signatures that you're expecting are here. And then you can automatically deploy that unit. So you don't need the manual, stop gap anymore. You have an automated way to do that. And then we come to the deploy. So deploying software into any of your environments. Usually you have like one environment at least before you go to production. That's, I think, still a lot of the standard way that deployment systems are thought out. Containerized deployments are a big thing in this nowadays. So Docker or containers in any shape or form, Kubernetes, all these kinds of things are playing a big role here. This involves also, beyond the developers and the quality analysts, also infrastructure specialists at some point in specific teams, depending on the setup. And when we're talking about deployment, it's a whole array of other things that we can do that are like obviously there's a lot of stuff, but the individual things aren't necessarily very sophisticated. So again, the question of whether we know if we have any vulnerabilities in our infrastructure, because infrastructure is code now. Our Docker containers come with a whole array of layers of dependencies that they pull in, and like they pull some operating system, all of that. Some are distro-less, but nevertheless, right? You want to make them small, and then you want to still be sure that there's no vulnerabilities in any of the dependencies that you require. A lot of the cloud providers nowadays have a way to do this as like, you know, a service. So it's more or less checking a box, and then you get a report that you need to pause and do something about it. But the plain scanning is usually available out of the box. If not, there's open source tooling that does that for you, that you can integrate into your pipeline. The other big thing, it's probably a little bit more difficult to do, depending on how, like, the ecosystem that you're in, is the question of segregating environments for access and data. So you want to make sure that you're using different kind of data in different kind of environments. You want to make sure that your test environment stays a test environment by making sure that the data that you have in that environment is test data and not production data. Now that seems like a simple idea, but in reality, it often isn't. So it's often not that simple to come up with a test data set, or it's just not in the process of what's happening around you. But if you have any influence on that, that gives you a lot of control and limits your risk in the environments where you want to experiment. You have your development environment because you want to experiment to a certain extent. You want to learn, you want to have this like fast feedback cycle. If you have production data in that system, you need to make sure you harden it as you would your production system. So a lot of the ideas kind of become a lot more difficult. The other thing is access. Role-based access is like one of the key kind of mentions here. How can we segregate access so that we comply or we adhere to the principle of least privilege? How can we make it so that any access that we have as individuals, or any access that any resources have in our system, are limited to the privilege that they actually need in order to do what they need to do? That's sometimes a bit of a tedious process, but it's definitely worth it, because it reduces your blast radius should something go wrong, especially in the distributed systems that we're building nowadays with microservices and a lot of, you know, different components talking to one another. If we rely on an outer layer control and do not think about ideas like zero trust, we say, how can we limit the potential of, you know, escalating privilege from one system to the other? Then again, how can we help ourselves not leaking secrets? There are tools out there that help us inject secrets at runtime. I think in ThoughtWorks, a lot of teams have made really good experience with HashiCorp Vault for that, or any built-in, you know, cloud provider secrets management system that prevents you from having to have these secrets somewhere in configuration code, or in environment variables, or even on your local machine. We also want to use short-lived privileges so that if something goes wrong, we can cut off the access in a rather simple manner. And we don't kind of have to expect that a certain token is valid for the next 2 years, but only maybe the next few minutes. And then the question of whether we're confident that we can recover from disasters quickly. And quickly means, do we even know how quickly we are expected to recover? Running disaster recovery exercises and scenarios on a regular basis isn't something that I've seen a lot in practice, unfortunately, but the context where our clients were, you know, letting us do that definitely helped gain a lot of trust in our own systems. And if you know, okay, I have to be back up with this system, I have to be back up within 2 minutes. In this system, I have to be back up within 2 days because of what the systems are doing. I can like concentrate my energy onto making sure that I can rebuild from scratch whenever I need to, and I'll bring up the system as it was before. That includes obviously backup strategies, but it also includes being really sure and having regularly tested, that I can rebuild my system from the infrastructure code that I have. There's a lot of circular dependencies that usually come up when you try to do this, even though it feels like you have the setup and the code handy and it's all described, right? But then when you actually try to do this, you realize all the dependencies that are there, and you can't spin up this one thing before this other thing, and this other thing not before this one thing, and then you're in a bit of a disaster. You don't want to find out about this when you actually have to. You want to learn about this as you go. Yeah, I think that's mostly it. Operating. So when we're operating our systems, we want to learn about real bugs in our real system, not things that we thought about might be a problem. We also want to learn about our real attacks in the real life. Right? So everything that we did before around threat modeling always bases on the idea that we kind of try to apprehend what's going to happen. But there's nothing better than learning from your actual system of who's interested to attack your system, in what way, and then defend against that instead. But that involves a bit more thinking around how do we use our metrics, what kind of observability do we have, what would we even be able to see. One of the questions that I often start with in the conversation about this is, would you know when you're under attack, and how? Do we know what normal looks like, right? Because only then we can define what's not normal and maybe start looking into that more deeply. If something actually has happened or is currently happening, do we find out how somebody has made its way through our controls? Because then we can strengthen our controls, right? But in order to do that, we need auditability, and we need append-only logs. We need logs that cannot be tampered with, so somebody cannot, hide their traces when they come into our systems. And do we know what we do in the moment where something goes wrong? So this is all about incident response, and actually, having a structured process of quickly and thoroughly responding to something that's going wrong without destroying any evidence that we might need to learn from what has happened. There's a lot of interesting concepts around the question of observability, right? So we've spoken about anomaly detection. How do I know what's normal? How do I know what's not normal? There's all kinds of AI systems that help you do that if you're in the public cloud. But there's also just ways to learn about your general, access patterns, and what do your metrics look like. Start looking at your dashboards early, even if you're not live, because that gives you a sense of what your system looks like. And then when you have a few users, you get a sense of what does it look like then, what does it look like over time when you have more and more users, etc. There's also the idea of intrusion detection, to be more clear about what parts of my systems are currently under attack. The tools like Snort that can help in that. There is the idea of thinking about indicators of compromise. What are the things that should make us a bit more alert? And can we actually formulate them into an alerting system so that we don't have to go look, but it kind of comes to us? And the idea of repudiation. One interesting thing that we can do here is called security chaos engineering, in order to kind of drive this a bit more proactively than waiting for a system to evolve. And that's based on the idea of chaos engineering, where Netflix, I think, has first started to try and see what happens if I stop certain parts of my infrastructure. Can we fail over? Are we resilient to it? You can do a similar thing with security. we have to be careful that we don't kind of train people not to look anymore, because I think it's this thing again, right? This is like automated thing that, that tries to teach us something, but it's a good idea to embrace. Yeah, so this is like the walkthrough or delivery lifecycle. It's a lot of things, you know, but every individual thing is bringing a lot of value. And I'd encourage everybody to pick the ones that are closest to your level of maturity, because we're all mature in our systems in different ways, right? So what's the closest to where you are at the moment? Try and do that and start with one and then evolve from there. And that's why I've put them together at the end. I don't know if you're sharing the slides, but and try to like bring out the principles of the different kind of, you know, areas of different sections. And the little red bar here is trying to indicate a felt level of maturity that you need, right? Because they all, or some of these things require a bit of a, you know, a baseline that you jump off of. You can't do anything about security around automated infrastructure if you don't have infrastructure as code. You can't do a lot of these things if you don't have a CI pipeline, right? So you probably want a CI pipeline first, but you can still do threat modeling. There's a few things, and you can still do stuff around the code that you're writing on your local machine. So that's a bit of a summary. Thanks a lot for your time. I hope I didn't take too much time, but I think we're still a little bit before 7, so that's good.
That was amazing, Lisa.
I think we're on time, so no worries. It was very interesting. It's up to you. Would we have some time for some questions?
Yeah, maybe not too much, but a little bit.
Just a little bit. Quickly going through them. Vanessa, do you have one ready?
Yes. So actually, I am curious. So for somebody who works on legacy code, how could they start to approach some of these techniques? Because we all know how it can be trickier when you already have a working system compared to when you're doing it from scratch. So what what kind of advice can you give to people who are currently working on legacy code?
Yeah, that's a difficult question because it kind of depends on legacy in what way, right? But I think one of the most important things, and this is not even security, but it helps a lot with security, is starting to do continuous integration. In legacy environments, it's usually really hard to do any kind of continuous deployment or delivery, right? But you can start formulating expectations in tests. So do test-driven development and use those tests in order to, to build confidence in the functionality of your system. And then from there, you can, like, that already gives you some, some security controls, obviously, because you have more like hand on what your system is doing. But from there, you can then jump off and do, actual security testing and things like that. I think that's one of the things. But if you have a legacy system that doesn't allow for proper secrets management, try to find ways to, to do this as best as possible, right? Is there ways to abstract things away? Is there ways to, contain different systems or different parts of the system from one another, right? So that, every mistake that you make doesn't get escalated into a bigger context. Threat modeling, right? Try to understand what influence do you have with your systems and like your team's influence in the system, and then try to understand what threats there are and bring those up to the business. And that can usually help drive a bit more modern engineering practices too. I hope that answers some.
Thank you. So on the topic of TDD and infrastructure, I think there's lots of debate in our line of business that people think that we can't test infrastructure or we shouldn't, or some people think that it's impossible to TDD. I personally, TDD infrastructure, I do believe it's more challenging that with different type of code. But if there's one place where you want to make sure that you're taking care of your security, is infrastructure. Not that you shouldn't elsewhere, but less radius, as Lisa says, right? So I will just, advise people to just give it a try. It will behave differently, especially if you're a purist TDDer. Sometimes you will have to write more tests than you would if you're a purist TDD, but give it a try, because you're going to get the same benefit that you get usually and apply it to everything. One thing that I've been told many years ago in my career was, when you do something, imagine how that would look on the front page of the news. And I use that as my guiding principle.
That's a scary thought sometimes. Yeah, definitely. I would agree. And I think the apart from the principle of least privilege, which I think is like an incremental, it doesn't necessarily require tests though, but like this incremental idea of like, doing something small and adding to it as you try and run a thing, so it can do, a component can do what it needs to do. I think that's one of the effects. The other effect, I think, is the encapsulation of things, right? One problem that I think is still not very well solved in our kind of maturity as an industry around infrastructure as code is what belongs together and what doesn't, and how do we distinguish these components from one another, and how do we make sure that, like, we know what needs to go first and second and after that. And that's TDDing or testing infrastructure, even though you're often repeating, because it's declarative code, right? You end up repeating a lot of the code that you're writing in your test code. It kind of seems odd, but it helps you think out the architecture of your infrastructure code, which we tend not to do so as much as we do in classic application development.
So we have a couple of questions from the chat. So if we just have not even 10 minutes, so we'll go through them if that's okay with you. Lucia is asking, do you think that having an external team trying to break your system, could that bring some value, or is it the other way around? What do you think?
Yeah, I think both is true, right? So I think, especially as developers, that's also sometimes the value of quality analysts, even if they're part of your team. It's really hard to build something only to then try and break it. Like, we can't come up with reasonable ways to break our own stuff. So it's usually helpful to have someone else try to break your stuff. So either we can try and automate things, as I said, and I wouldn't even say either, but this end, we should bring someone in to try and break it. Definitely. That there's a lot of value. The thing with the bringing someone external in is that it limits the amount of times that you can do this, right? So especially thinking of classic pen testers, they're really expensive, and you can't bring them in like every 100 commits that you commit a day. Like, this is just not a reasonable thing to do, but you can do automated things in your pipeline, or you can have checks with your teammates in your team. But yes, that doesn't replace an external team trying to actively break your system. There's always more to find.
Sure. Thank you, Lucia, for the question. And then we have one question from Juan. He says, I have seen sometimes that to maintain security in projects, we tend to use just a checklist. Right? How do we know how to add something else to check and be proactive for the security?
I'm not sure I understand fully, but did you?
No. That's his question.
I'll try to respond, and Juan should let us know in the chat if I'm answering a wrong question. So that's why you're trying to do the threat modeling, right? You're trying to step back and try and think from a different perspective of what would be disaster scenarios? What could I do to what we have in order to, make something massively go wrong or small go wrong? And how can we then from there, you can start trying to phrase that into your requirements, right? And come up with ways to increase your checklist. Some of these things that you find in threat modeling exercises, they become a standard in your checklist, like before, the definition of done or definition of ready or whatever people call it, right? Some of these things are just so repetitive that you're like, oh, maybe this is a thing that's kind of, and defines our system in a way that we always need to look at that. And then that's what you do. Right?
I think it kind of helps to have it always there because, it will be part of the way you work. However, on the other side, we have probably to be aware that this shouldn't be static. Otherwise, we lose this idea of adapting. That's how I understand. Juan, please let us know if we did answer your question. I think we are approaching the end, given the time constraints we have.
I will show the slides. Give me a second. In general, I want to say thank you to Lisa. This was incredibly useful. You definitely should be writing a book. Please tell me if you can see my screen with Lisa's face.
Yes, we can. By the way, Juan acknowledges we have answered his questions.
Nice. So next events. So we will have Matteo Vaccari, the 20th of October, with a talk, which is about accelerate development with simple design. And the 27th, we'll have it in English. So when we have speakers that speak two languages, because the community was born in Italy, we try and do the talk in both languages. If anyone else would like to do that, please let us know. So we always make sure that we have an English one because it tends to be the common language. But if there's any preference in general, people, please let us know because we have people from all over the world and it might be possible to arrange something. So I'm sure this is going to be as interesting as all the other talks that we had. So we really suggest that you come and join us. Also, we love the conversation. So please keep it up. In general, we love your feedback. All of you who are here tend to be on our meetup page. Please email us. Let us know what you think, even suggesting the kind of things you're interested or, whether we could change the format, anything that could make this experience better for you. And I think my colleagues and I want to thank you and Lisa for today. Have a lovely evening all.
Thank you, everyone.